Hello, everyone. Thank you for joining us today for this first TSB webinar with Pure Earth. So I'm very happy today to be your host and moderator. My name is Timothy Dulac. I am an account director for Pure Earth in the Americas region, working closely with those TSB suppliers and making sure they can achieve their certification using our TSB methodology. So we'll give it maybe a little bit of time for people to join in. And then we can start this webinar with our Superstar TSB panel. All right. So in 2023, Pure Earth published our first version of our TSB methodology. And now we've seen in those past 2 years a lot of traction, a lot of new developments in this industry and in this CDR activity. And so earlier this year at NNCW, we hosted a first workshop with scientists, with suppliers, with Puro as well, talking about this pathway, showing that it's credible, that it's working, that it's high integrity. And today we wanted to have some continuity and host this webinar for all the ecosystem at Puro and in the CDR industry as a whole. So I'll be sharing my screen for the presentation. So welcome everyone to this first TSB webinar called From Standards to Impact, Operationalizing Terrestrial Storage of Biomass for High Integrity Carbon Removals. So a little bit of practicalities before we dive with our speakers. So please do write your question in the Q&A chat here. We'll address them at the end of this session. If there are any unanswered questions, I'll make sure to follow up with them after the webinar. And or you can contact our contact email, contact@puro.earth. This webinar will be recorded as well, and you will be able to watch it afterwards. So you don't have to take notes. You can just listen in, absorb all of the information from all of our partners here, and be fully focused and tuning into the session. And then finally, we encourage everyone to send feedback at the end of the session on how we can improve this and make it better for the next time. So in the agenda today, we'll dive first into the science of TSB with Dr. Zhang. And then we have a lot of suppliers and partners from the TSB ecosystem at Puro. We have Woodcache, Cow Carbon, Mast Reforestation, TimberTurn, and an ecosystem partner, Leading Carbon, with Keith Driver. I would like to take 30 seconds to thank Keith Driver, especially for his work and all of his help to organize and collaborate for this webinar. He is a key part of this TSB ecosystem, and he will be speaking at the end and adding a few words. So we'll wrap up with the Q&A session and closing remarks. I think that's about it for the introduction. So without further ado, I would like to introduce Dr. Zhang, professor at the University of Maryland. And he will be presenting a little bit of the science to just have everyone getting caught up and catch up with the best available science at the moment. And then we'll dive into the supplier overview to that. So Dr. Zhang, feel free to share your screen.
Do you see my screen now?
Yes, perfect.
Good morning, everybody. Thank you for coming to this webinar, and I want to thank Puro for organizing this and Case Driver in particular. So I will start by saying that durable CDR is in short supply. Biomass burial provides a opportunity that can actually satisfy this demand that is really now a very challenging situation for our climate goals. So I want to put the context in a general, what we typically now say, nature-based versus tech-based engineering methods. This, some of us argue, belongs to a category we would like to be separated, called the hybrid nature engineering solutions. We go beyond just planting trees, but we do take advantage of natural processes such as photosynthesis, but add significant engineering. It's not just plant a tree and leave it there. So it belongs to this whole category of hybrid nature engineering methods. I consider, for example, three examples: ocean alkalinity enhancement, and enhanced rock weather, and finally biomass burial. So these are recognized now as a promising methods that we can intervene significantly into the natural carbon cycle, but enhance the natural processes by orders of magnitude, so we can achieve durable carbon removal goal. So first, the terminology, as you can see here, there are different names for it. Wood burial, wood harvesting and storage. Harvesting means actually important aspect, that is sustainable wood sourcing. Biomass harvesting and storage, woody biomass burial, terrestrial storage of biomass, subsurface biomass storage, biomass burial, which is actually catching on among several major CDR platforms, for example, the Oxford State of CDR Report and World Climate Research Program, and so on. So, of course, just like any other names, it has its own course. So we cannot control it. We have probably each have our own favorite name. And I'm here recommending using the name biomass burial and storage to be sufficiently encompassing, not just tied to, let's say, one company or one scientist's most favorite way of doing it. But of course, it's really up to the community. So I definitely acknowledge this and we'll see the terms probably evolve over time. What is biomass burial and storage? Collect sustainably sourced woody biomass, such as natural waste wood, buried in specially engineered structure. We call it wood vault. So wood vault is an engineering structure that ensures the carbon is removed for a long time. We, in fact, target a durability of greater than 1,000 years, although not just you randomly dig a hole will ensure that. But so there's a whole engineering methods there. Currently, the cost is between $100 to $200 per ton of CO2 and has very low capital investment. Carbon efficiency, meaning CO2 emissions related to the operation, excavation, and so on, is typically less than 5% of carbon sequestered, and it's distributed and highly scalable. And we believe it's ready to deploy at megaton scale right now, provided there is financial support and logistics are arranged. And we think it can reach gigaton scale in the 2030s. And there are now two international standards, one by Puro, one by Isometric, although there is a implementation guidance put forward by a group of academics on wood harvesting and storage, or WHS. So a short history of WHS. In the earlier days of concern of a climate idea of mitigation of climate change, this word pickle tree actually floated around in a small group of experts. Then 2008, a first paper specifically on this idea was published. 2013, a consortium of scientists supported by Oak Ridge National Lab estimate a up to 10 gigaton per year scale for this method. Then two research projects were conducted in the subsequent years. In particular, the 10-year Montreal project actually buried 35 ton in a real burial environment, showed that in particular, tackled the durability problem, showed that it can really preserve the wood for thousands of years or longer. Then now I can count at least a dozen or more companies that are implementing this method. Several of them are going to present their specific approach and effort. And several research institutions are also have been doing research on this. I have actually been collecting papers. I have a list. Anybody can send me an email, and I'll be happy to share. The scientific basis from a carbon cycle perspective is like this. The biosphere is super productive. The terrestrial plants alone, excluding ocean, each year captures 220 gigaton CO2. That is 6 times much as our current fossil fuel emissions. In the natural carbon cycle, pretty much all of that is cycled back into the atmosphere in relatively short time scale as leaves fall and trees die and decompose. So the net balance is pretty much in equilibrium, net zero. If we can siphon off 5% of this photosynthetic product in the form of woody biomass, put it into long-term storage, that translates into a 10 gigaton, 5%, 10 gigaton per year of carbon removal potential. And this, of course, is not to say cut down the forests in order to bury it. You actually want to maintain the forests, healthy forests, like you raise the chicken for harvesting the eggs. You want to keep the chicken healthy, so you can harvest the products. While in comparison, planting trees is grow the chicken for the chicken, and wood vaulting is grow the chicken for the eggs. So essentially transfers the carbon from the fast biological carbon cycle into a slow geological carbon cycle. So how do we actually implement it? A standard poster child version is what's called a wood vault, directly bury the carbon underground in a oxygen-free condition by using no permeated clay soil and waterlogged condition and so on. And it's relatively shallow, typically a few meters below the ground, depending on, of course, the soil and hydrological condition. But it's below the active biosphere. For example, biochar typically is applied in the active biosphere, so it's still subject to biologic degradation, oxidation, so on. While wood vaulting puts it below that level into a geological layer, which is stagnant and inactive. And this is very similar to the first step of the coal formation process, where naturally vegetation in wetland, which is somewhat oxygen depleted condition, is preserved until it's buried into
Thank you,
certain
Brady.
depths.
So this is typically what a post-wildfire site looks like. Here you see
Sorry-
all of the
sorry,
standing
Lisa.
and lying dead
Can-
trees.
Sorry,
And
Lisa,
this
can
is
you
the
can you
biomass
mic
that we
your
use in our burial projects. In one,
So when it's deep enough and it becomes coal. So in this case, unless it goes into a geological state, it doesn't stay as raw wood. So this, of course, is done, instantaneously on geological time scale. So some people call this a reverse coal process. So the engineering aspect, we have proposed 7 versions: above ground, below ground, and underwater or in freezing conditions. The engineering, the actual construction of a buried version of wood vault is somewhat similar to the construction of a landfill. So there's often a confusion thinking it's landfill, but it's actually not. Fundamentally, landfill is only partially anaerobic at depths. It uses food scraps with high nutrient condition, toxic chemicals, and it's actually a bioreactor, typically hot. While a wood vault is anaerobic, absolutely anaerobic, zero oxygen, clean wood, very little nutrient that does not supply bacteria community, and it's cold. An important concern about methane generation. We think it's negligible, though more research is needed how to actually engineer in the right way. And it's stabilized after weeks to months after minor decomposition, unlike a landfill where most of the organic matter is consumed after a short amount of time. So now I wanted to address 2 major challenges with biomass burial. Number 1 is durability. Number 2 is sustainable wood sourcing. So compared to injecting pressurized CO2 underground 1 kilometer down into deep geological formation, where you have to deal with high pressure CO2, here it's a very different problem. The biomass, woody biomass, is very stable, it's solid. However, it's prone to biological degradation in the natural environment. So the decomposers need 3 conditions: oxygen, suitable moisture, and suitable temperature in order to survive. If we can cut off any one of the 3 conditions at high fidelity, we can preserve wood for a long time by preventing biological decomposition.
Thank you, Doctor. Sorry, could you please wrap this up in 30 seconds? Thank you.
Oh, okay. So let me then fast rewind there. We do have a lot of geological, archaeological evidence to support the high durability. However, how to engineer in that condition is not trivial. So that's what the community needs to pay attention to. Then wood sourcing is as critical issue as durability, so we need to pay attention. Good news is we have a lot of people paying attention to this. So finally, I'll conclude that wood harvesting, storage of biomass burial in general, and storage is simple, practical, and it's scalable now. So I'll put my conclusion up there for a second before I turn it away. Thank you.
Thank you, Doctor. And I would like to emphasize that our methodology and our protocol are actually based on your research, on your science. So thank you so much for being here with us today. I'm happy to see also my hometown Montreal being mentioned as a pilot project here. So we'll continue on now to the next part of this webinar. So first we wanted to have an overview of the history in the science, and now we have Serge from Woodcache. Serge, you have 5 minutes, so rapid fire to present your organization, etc. Go ahead.
All right, very good. Thank you very much. My name is Serge Bushman. I am representing 2 companies today, one called Woodcache PBC and one called DuraVault. I'll also tell you about direct biomass storage, an emerging term for the carbon dioxide removal activity underlying the terrestrial storage of biomass methodology. Direct biomass storage can play a significant role in addressing the climate crisis, and in my opinion, is scalable by an order of magnitude each year until the early 2030s, such that it has the capacity to remove a new gigaton of CDR each year in perpetuity. Here you see Woodcache PBC in our experience executing direct biomass storage, and that we grow at an order of magnitude or so every year, and that we can continue to execute that growth rate on the left. On the right, I show that basically this is actually working, and it is doing the things that are required by the methodology, the TSB methodology, and also contributing in increasingly significant ways to the remediating the climate crisis. I have a lot of opinions, and I've summarized some of them on the bottom half of this page for future discussion. Today, I want to share what I think is the primary reason direct biomass storage is not scaling faster. The unequivocal first order answer is that in the top left there, the lack of demand for direct biomass storage credits prevents growth in our sector. This may seem like a trite answer to many of you, but in several other CDR sectors, there are lots of other reasons CDR doesn't scale, like the inability to deliver CDR at all, or the inability to deliver cost effectively, or science problems, or engineering problems, or MRV problems, or regulatory problems in direct biomass storage. Each of these problems have been solved or have line of sight resolution. Make no mistake, limited demand is the one and only reason direct biomass storage is not a bigger industry today. In turn, perceived limitations on durability are the primary reason demand for direct biomass storage is not increasing faster. Buyers representing the majority of the market reject us because we're not perceived as 1,000-year plus years durable. This perceived limited durability is at least in part due to Puro.Earth's TSB methodology, which acknowledges only 100+ year durability. In turn, I believe that Puro.Earth's conservatism is merited because the current risk of reversal is perceived to be high. Please note that this is different from saying the lack of durability results from weakness in underlying scientific theories or observable evidence. Allow me to elaborate. Archaeological observations that Dr. Zhang has collated are replete with wet and dry examples of 10,000-year durability, and examples from modern landfills demonstrate how wood decomposition immediately slows to a fraction of the natural rate and eventually stops over the course of decades, becoming permanent carbon sinks. These concepts are well known to Puro. What overcomes the scientific permanence is the perceived risk of reversal. Reversal could result from any number of things, and it is a consideration in every single CDR pathway. In direct biomass storage, reversal might come from fire, infestation, wood rot, flood, or even humans digging the wood up. These risks are pretty nebulous and in reality unlikely, but they lurk in the back of everyone's mind. I'm arguing here that the risk of reversal is the reason why Puro.Earth does not acknowledge 1,000+ year permanence for TSB. I will further argue on the next page that the risk of reversal, perhaps uniquely to direct biomass storage, is addressable. And with the right mechanisms, reversal risk can be reduced. Then durability ratings can be increased, the financial value of direct biomass storage credits can go up, and demand can grow more appropriately in line with those who currently reject direct biomass storage. This brings me to a description of a new company called DuraVault. It is co-owned by direct biomass storage developers and other industry participants. There are loose equivalents to this service provider model in other industries, including agriculture, marketing, franchising, and partnerships. DuraVault's primary objective is to deliver durability to the market. It does so by managing and delivering a combination of its producer clients' long-term assets and liabilities. These could include cutting-edge systems, including site-based and digital measurement, reporting, and verification systems, trust and endowment services intended to fund long-term management, and more importantly, intended to show the market that resources are available to fund long-term management, and direct management of facilities and digital assets. In short, DuraVault draws upon funds held in trust to maximize the likelihood of 1,000+ year durability. DuraVault also offers scale economies for producers in numerous areas of interest, including R&D, equipment, software and new software development, interaction with Puro, insurance, responsible and transparent trust management, and legal services. Combined, DuraVault can deliver long-term management services and bring to bear long-term financial resources that can lower the risk of reversal to infinitesimal levels. Confident in this management, Puro can eventually increase its durability claims for direct biomass storage. Thank you very much.
Serge.
Welcome answers to questions after everyone else has presented. Thanks.
Thank you, Serge. Great presentation. Thank you. So now we'll go on to John Lynn at Tau Carbon.
Hi, everyone. Timothy, are these slides showing up for you?
Yes.
Yes.
Okay. All right. Well, thanks for inviting me here today. I'm John Lynn, co-founder and CEO of Tau Carbon. We're the company within this methodology that's doing above ground dry biomass storage. So I'll be talking a bit about how that's a scalable, verifiable, and durable carbon removal approach. So here is the basic breakdown of our process. We're aggregating wood waste. It can be from a managed forest, from a natural forest. Out here in the American West, forest thinnings to mitigate wildfires are a preferred source. We then densify that material. So rather than store the wood as logs or branches without processing, we chip it, dry it, and then press the dried chips into a briquette that's 3 times more dense than a log. And then the final and most important step is to build an above ground storage container. And that's made of modular fiberglass panels in the shape of the picture you're seeing right there. We stack the briquettes, palletize them, and in a container that's only 6 meters tall, we can get a storage density of 40,000 tons of CO2 equivalent per acre, which we're quite excited about from an economic point of view. And the fiberglass material itself is rugged and withstands, natural forces for more than 100 years with minimal maintenance. That allows us to claim the credit under the methodology. So our real source of excitement in all of this is cost. So on the left-hand side, you're seeing 2 plots, unit cost on the y-axis, scale on the x-axis, and you're seeing how our costs vary with the scale. I direct you particularly to the international operations plot because at a modest scale of about 100,000 tons per year, we're well below $100 per ton in unit cost. And even in the US, we approach $100 per ton. And the driving force for this is the simplicity of the process, using very little energy and wasting very little carbon in terms of process CO2 emissions. So in these plots, you see obviously the contributions of the various components of the operation. Our costs decrease with scale, with that being concentrated in heavy equipment and labor. And then what we're really excited about is that you're really only seeing the first version of what Tau is doing. We're using fiberglass tanks. They're meant to store water. They haven't even been optimized to store wood yet. The material hasn't been made more efficient in terms of how much fiberglass we have per panel. So those things are going to happen over time. We'll automate the process to make it more efficient in terms of labor usage. And then we may actually make our own FRP in the future to bring those costs down. Okay, so we're operating within this TSB methodology, and one element of TSB is dry storage. So I just wanted to give a few bits of information about how that works. The key for us is maintaining a low relative humidity in the storage tank. And so if we keep the humidity below 71%, that prevents all biological decomposition. Fungi, microbes, anything, insects that could possibly digest this wood doesn't function in those dry conditions. So we have 100% preservation. And what we're excited about with our tanks is that we're passively maintaining those conditions without doing anything. We monitor the conditions inside the tank to verify the integrity of the storage. So we're monitoring humidity, temperature. We could detect CO2 and methane, which would be any indication of decomposition. We then provide a funding mechanism for the long-term maintenance of the site with a combination of a trust fund and insurance, which can be flexible. And then you heard some mention of the sustainability of feedstock and that being a concern. And the Puro methodology is very meticulous and comprehensive in terms of the rules it sets out. And so we can source, as I said, from managed forests or natural forests, and those requirements are summarized briefly in the text. I want to tell you a little bit about our pilot that we're very excited about. This is going to be in the southwest corner of South Dakota called Project Pioneer. We're planning to issue 30,000 to 50,000 corks by the end of 2026 with a unit cost under $150 per ton. Our feedstock sourcing would be from the Black Hills National Forest, where there are timber operations that generate piles of tops. These are the tops of trees that are not otherwise used. They're typically stacked and burned, so we'll be pulling those out of the forest instead of burning them and degrading the local air quality. And then most importantly, in South Dakota, there are no zoning restrictions. There's no above ground zoning that will restrict our ability to erect above ground fiberglass tanks. So it gives us a chance to pilot this technology flexibly. And I did want to mention for the buyers in the audience, we have the option of multi-year offtake, prepayment for the corks that we're going to issue, and possibly direct investment in Tau. And if direct investment is of any interest, let me just finish with a bit about Tau's business model, because it's a combination of Tau directly owning sites and licensing its technology. So generally, we'll license to entities probably operating in lower cost countries where they use Tau's technology, pay us a percentage of their revenues. And that allows us to operate in environments where the legal and political considerations would be hard for us to navigate, and also expand in a very capital light way. But we also plan to have our own directly owned sites, probably in the United States, where we are continuously developing the technology behind what we're doing, the storage containers, the sensors, the processing. And we're very excited about the possibility of aggregating more biomass than we plan to store and then selling the excess as feedstock. So hopefully I haven't gone over time. It's probably a good place to stop. I just want to thank you all for the chance to present, and looking forward to your questions.
Thank you, John. This is great. So that was another American project. And now maybe we'll move to Canada with Kartik from TimberTurn. Go ahead, Kartik. And maybe just for everyone to know, obviously John is the CEO of Tau Carbon, Kartik is the co-founder as well, and Serge as well. So you're really talking to the people that have started those companies since the beginning and all the efforts to make it happen. So go ahead, Kartik.
Thank you so much for this opportunity. My name is Kartik Narula. I'm the co-founder and CEO of TimberTurn. We help landowners, forest licensees, and indigenous communities manage their forest waste. Our focus is on underground biomass storage, especially for wildfire-prone materials such as mountain pine beetle fir. We also support post-wildfire ecosystem restoration and have active projects here in British Columbia, Canada. The next slide will showcase the impact of mountain pine beetle on wildfires. And this video is from one of the communities that we work with. They have been forced to evacuate due to wildfires multiple times in the past few years. This has caused habitat and biodiversity loss, and there's no market for this biomass and no way to finance the cleanup. So what causes wildfires? To start wildfires, you need three things: oxygen, heat, and fuel load. And due to climate change, conditions are drier and warmer more often. Plus, fuel loads in the forest have increased multiple times in the past, and that has multiplied the risk of wildfires. So what is the solution? The solution is active fuel load management, and we need to actively manage forests, that is to reduce their density to safe levels. The effect of that would be increasing carbon stocks and reducing wildfire risk. And the idea is to increasing above ground forest stock, carbon stock by forest management, and below ground carbon stock by strategies such as burial and biochar. There are, however, a couple of challenges to this. Number one is, what do you do with all the biomass? Sadly, especially in the remote areas, it's often burned, which is not a great alternative because all the carbon in the biomass goes back into the atmosphere. Second, it's expensive. Estimates show that you need $1 billion to thin just 1 million acres of forest. Previously, governments and timber sales used to help fund that, but now we need new ways to finance this given the scale of the problem. And the obvious solution that we are talking about here is carbon finance. This slide shows typical way how residual biomass is treated by burning it, which releases all the carbon back into the atmosphere and causes lots of other problems such as air pollution and harm to the community. We currently have 2 projects right now, one on private land near Beverly, BC, and it would source the feedstock from mountain pine beetle infected timber supply area. That's 8 million acres of forest that is impacted by mountain pine beetle and poses severe wildfire risks. Second project is on a First Nations territory, which is currently in feasibility stage and is funded through grants. And for buyers' point of view, we are actively looking for optics and pre-sales for 125,000 tons. And we would store 25,000 cogs for the next 5 years. Yeah, I'll end it here. Thank you so much. Please feel free to contact me for any questions.
Thank you, Kartik. This is great. Perfect. So now we'll wrap it up with our last supplier of the day, and but not least, obviously, with Mast Reforestation and Lisa. I think it will be Brady also from Mast who will be sharing his screen. Perfect. Thank you.
Yeah,
Please go ahead.
Thanks, Tim. I appreciate it. Hi, everyone. Nice to see you all. And to all our fellow presenters today, thanks for your overviews. As always, I enjoy seeing your approaches. My name is Brady Perrone. I work at Mast Reforestation, and I'm a director of carbon market partnerships. And I'm joined by Lisa, if you want to jump in quickly there.
Sure. I'm Lisa Gonzalez-Kramer, Vice President of Forest Carbon Programs, actually joining you from rural Montana at our MT1 project site that we'll be talking about today. So happy to be here. Thank you.
Wonderful. So if you are not aware of Mast, we're a Seattle-based vertically integrated reforestation company. And as you can see on this slide, we have 2 nurseries that are part of our family of companies, Silvaseed and CalForest. And through these 2 nurseries, we manage the majority of seed for the northwest of the US and grow the majority of seedlings for the state of California as well. We are very squarely focused on scaling the restoration of post-wildfire landscapes. Our mission is to restore forests that are destroyed by wildfire and preparing the landscape for restoration, as Kartik was just talking about, after fire. It's extremely costly, especially dealing with the dead burnt biomass post-fire. And so in this photo, you can actually see our MT1 project that Lisa is literally working on with the team today and for the past few months. And we'll tell you a little bit more about that shortly as well. This is really the problem that we're working on, which is that forests are burning hotter and more intensely, and they're struggling to regenerate, and they need human intervention. And so we believe that biomass burial is a really innovative solution to financing post-wildfire restoration, and are very excited about it. And Lisa, I'll pass it to you, and you can share a little bit more about our approach.
Thank you, Brady. So this is typically what a post-wildfire site looks like. Here you see all of the standing and lying dead trees, and this is the biomass that we use in our burial projects. At MT1, our project site in Montana, the landowner was fortunate to receive funds for post-wildfire cleanup. So on the next slide, here we have an aerial view of the MT1 project site before Mast met the landowners. Every white circle shows where a stack of decked wood was located on the property, and there were approximately 240 piles of unmerchantable logs on the property. So what happens without biomass burial? What is the counterfactual in our case? Well, traditionally, that dead woody biomass is often left to decompose, as shown in the previous slides. potentially becoming fuel for future wildfires. However, in our scenario, landowners have already cleared and piled the biomass, intending to burn it. The landowners primarily burn the biomass because the piles are an eyesore, a persistent fire risk, and burning is the most cost-effective disposal method, and many states encourage the biomass burning. Mast's restorative carbon removal, dioxide removal pathway, or our restorative CDR pathway, offers a compelling solution. We offer the landowners the opportunity to bury the biomass instead, and in exchange, Mast provides reforestation in the biomass sourcing area. So this not only helps landowners restore their forests, but also delivers significant co-benefits for our buyers, including the crucial reforestation services that we need in the Intermountain West and habitat restoration as well. So let's talk about the solution, the biomass burial, and we're going to break it down into the steps that we're approaching this as. So we're taking dead woody biomass from the same property on which we're burying it in engineered chambers. And I'm excited to announce that we're almost finished loading logs into the MT1 chamber. So final log placement tomorrow. We're very excited about that. And yeah, we're going to definitely celebrate 5,000 corks. So we partner with reputable engineering firms with decades of experience in landfill design to create these chambers that ensure anoxic and very low humidity conditions, effectively halting decomposition. Our chambers incorporate low permeability clay-rich soils around the chamber and advanced cap design to prevent water intrusion and diffusion of any potential GHG leakage. While burying logs is an inherently simple solution, everybody thinks, oh gosh, that's got to be very easy. We do ensure our biomass burial chambers are engineered to ensure durability through rigorous science and partnerships, including partnerships with the Idaho National Laboratory and other academic institutions. And we also ensure integrity and permanence through rigorous sampling, as you can see Zach here doing some moisture sampling, and continuous monitoring for temperature, humidity, and potential GHG off-gassing post-closure. So as a vertically integrated reforestation company, we're concurrently growing the seedlings needed to restore the forest in the wood sourcing area. And back to you, Brady.
Awesome, thank you. So as Lisa said, our project that we're working on right now in Montana is Mast Wood Preserve MT1. We estimate about 5,000 corks for this phase of the project, with about 125 acres of reforestation that's non-credited as a co-benefit. We're anticipating these 5,000 corks in Q4 this year, so ready for retirement. And we're also very happy to share that we got a triple B pre-issuance rating from B0 Carbon. We've got a very high level summary table from our B0 Carbon report there. You can feel free to scan that QR code if you'd like and take a look at that report. Since that report was issued in March, we have made some improvements as well. So if you do download that report, we'd be very happy to meet with you and answer any questions, but then also explain how we've improved from this as well. And we are at time. So the last thing I'll just mention here is that there really is a trifecta of benefits for landowners, for carbon buyers, and for project developers working on biomass burial and purchasing biomass burial. We think it's a very exciting and innovative solution, like I said, and like Lisa's pointed out, for reforestation and restoration post-wildfire in particular. And of course, we'd be happy to chat with you more at any time. So thank you very much, everyone.
Thank you, Lisa and Brady, for this. And now we'll move on away from the suppliers to the partners that are helping them achieve their goals. So I would like to give the floor to Keith Driver. Go ahead, Keith. I'm not sure if you have a presentation to share or you just speak. Up to you.
No, I thought I'd just speak from notes. I took some points here that I just wanted to emphasize on behalf of those that are really doing the work. questions that would come up and try and respond to them. The first is, is this nature based? And I think from looking and seeing all of our speakers today, this really does tie back to a nature based solution, and it's so integrated with, in the case of Mast, with wildfire cleanup, with the with John in terms of cleaning up the tops piles and getting that fuel out of the forest post forest operation. The next is, where do we fit in this sort of tech-enabled CDR? Ning mentioned that we're sort of a hybrid solution. I think that's a very clever way of looking at it, because when we step back from this, Zach is the director of capture, lots of technology, lots of CapEx, but really this is the biological equivalent of it. And as my partner Bart would say, this is back. This is biological air capture. And I think from that perspective, nature has done a great job of giving us mechanisms to capture that CO2, and we're just closing the loop on that. The third is biomass utilization. Why aren't we using this for biochar? Why aren't we using it for bioenergy? And my answer to that is, all of these solutions fit into an ecosystem. Kartik, I believe, brought up the point of, well, they're working in areas that are a long way from anywhere. And so that biomass can't make it to a final solution. And so this is part of that stack. We're not taking, someone yesterday asked John Lynn and I about it and said, well, why don't you just take 2x4s? And, obviously not. There's higher value uses of those. Lisa at Mast talked about using non-merchantable wood. I mean, that wood, once it's been burnt, really doesn't have a lot of options for use. Scalability. I think the low capital cost and the ability to convert these projects to look a lot like options on CDR volumes. So you can deploy a cell or a vault or the language that's used in the industry and pull credits within a 12 to 15 month cycle, so that there's this short-term investment to delivery of credits, which I think is tremendously advantageous. Is it proven? I think you're seeing pictures right now, Serge's slide of how they went order of magnitude by order of magnitude, prove that this has been done, and it's been done inadvertently in some cases in terms of wood that's made its way into landfill, and now on purpose. And the last one, is it organized? And I think if you look at the stack, is the science has been done. There's lots of work being done in that academic community. There's the technology that's being developed either from above ground storage or for building better underground storage components. The protocols there, we've got Puro with this robust science-based protocol. MRV is being completed. Folks like Serge, who's putting together these platforms for people to scale that. Same with John Lynn for above ground. And then we're starting to see those credits come and get delivered to the market. So I think it's a really exciting time. If we benchmark this against where biochar was years ago, we're seeing the technology mature. We're seeing credits come to market. We're seeing all elements of the supply chain get proven out in any number of applications that are responsible in the concept of managing the overall ecosystem. And I think this is a very exciting time for me to be here cheerleading. One shameless plug, we do have the TSB Coalition, which is a collection of TSB enthusiasts, technologists, researchers, and otherwise under the Carbon Business Council, and we're working together to support the industry and share key learnings early to support scalability. So thanks very much, Timothy, and just happy to see this event go on. So thank you very much to Puro for that.
Thank you, Keith. This is great. And yeah, I think this is the first time that we're publicly announcing that there is a TSB coalition that has been formed. So that was one of the goals of the webinar as well. I think we're trying to build all the momentum that we need in TSB. So all the industry players are talking to each other, are getting involved. Puro at a standard level is also involved in that coalition, following closely what is happening. And we brought in all of our suppliers that we can think of and prospects to be able to share learnings, knowledge, experience about what is happening in this TSB world and what does it look like on a daily basis, and how can we address the bigger challenges that some of those suppliers and partners have talked about today. So I'm gonna go ahead and move towards the question. So I'm gonna go and check our chat. So bear with me. All right, so perfect. We have 10 minutes for Q&A. I apologize, we might not be able to check all of them, but let's start with one. All right, so how we can do this, if anyone from the participants and the speakers want to answer this question, please do raise your hand or just jump in as we do it. The first question is an interesting one. Given the increasing cost for labor, materials, and fuel, how do the presenters anticipate meeting the calls from buyers to reduce the cost of TSV credits going forward? So let me say it again. How do the presenters anticipate meeting the calls from buyers to reduce the cost of TSV credits going forward? Who would like to take this one? Serge, go ahead.
I'll just say one part of that, which would be the questioner has asked an appropriate question and also identified that there are key costs that we all have to bear. And those include getting wood, moving wood, and storing wood. And those are all things that are labor intensive, machine intensive. And one thing is that those are things that we all encounter. Now, the question is whether for each of those components, we're able to figure out how to get something subsidized. And in a lot of cases, what we're able to do is piggyback on other activities that are occurring, which potentially reduce costs. But there are any number of operational efficiencies that can be explored as well. That's it for me.
Go ahead, John.
Oh yeah, I would just add, I think I think these cost considerations are things that all CDR companies are going to face. So just to pick biochar as an example, biochar's operation looks very similar to a TSB. They source wood, they dry it, they chip it, they need it, feed it into a machine. So, if you line up biochar and TSB right next to each other, our cost structures will be quite similar, except that TSB stops, before the pyrolysis. We don't need to be worrying about the cost of importing and sourcing those pyrolysis reactors. Any other CDR technology, weathering, direct air capture, they're all staring down the barrel of these higher costs. So I think in general, it's just an inflationary environment.
Perfect, thank you. Then we have a more general question. Same thing, if anyone from the panelists wants to take it, go ahead. The question is the following. What is the ultimate end goal of the woody biomass stored? And will it ever be removed from this container? So I think Dr. Zhang touched on this at the beginning of this webinar quickly. And I'll tell you right now, the goal is that it will never be removed from these containers. And we have requirements in place at Puro, such as, for example, one of them is putting in place a land easement of at least 100 years to make sure the TSV vault is never going to be digged out. So is there anyone that wants to add something from the panelists? Go ahead, Serge.
I would just say that what we're asking in that question is, do we trust our future selves? Will our future selves decide that the environment is not important, therefore we'll pull out all the wood and we'll burn it in a campfire? And, the big question is, will that happen? An important thing to consider that I think a lot of people forget is that it's not that easy to take all that wood out. It would take a concerted effort to take it out and use it in some other way. And then the other thing about it is that, someday it's potentially true that taking the wood out and using it in another way is consequence-free. No emissions for burning something, for example, someday. And what I think the big question is, do we trust our future selves to do the right thing at the time?
Go ahead, John.
Sorry, just me and Serge. I would urge people to maybe try to think a bit more open-mindedly about this. Yes, it's possible to say, oh, you're taking wood, you're putting it in a box or underground, and that's a waste. It's actually a CDR utilization. We're achieving CDR here. And I think the reason all of us on this webinar are so excited about this approach is that we can unlock scale that's not really happening or doesn't really seem to be in the cards for biochar or BECCS. Just think about the simplicity of what we're doing. All we need to do is aggregate the wood and store it. Whereas, say with the BECCS plant, you need to build a power plant, connect it to the grid, capture the CO2, pump it, put it through a pipeline and find geologic storage. By getting rid of those sort of extraneous steps, I think we're unlocking a lot of scale, and that's what we're excited about. So we're utilizing it for CDR.
Thank you, John. I think I have another question, and I think that might be more for Keith here, is what is the role of the TSB coalition and what are the goals for this year? Maybe Keith, you want to take this one, or would you like me to take it? Maybe I'll speak on it a little bit. So the TSB coalition is basically an organization with all of the partners and the suppliers and the ecosystem builders that we can bring together. So you've seen DuraVault from Surge, for example, here today. This new service came out of talks there on making sure that we wanted to tackle this reversal risk, and that sometimes it cannot be done at a project level. It has to be done at an industry level where people can help each other and make it work, right? So it's still new. You'll see more announcements in the future about this coalition, but I really believe in it. Just so you know, we have participants from Europe, from the Americas, like we had today. We will also have suppliers. I'm thinking of, for example, Facera in Australia, who were unfortunately was not able to be present with us today. But TSB is becoming worldwide, and the TSB coalition is helping drive this change and its adoption in multiple countries while addressing the challenges that TSB may encounter. Go ahead, Serge, if you want to add to this.
Just quickly, a key part of it is growing the market for TSB certified projects.
Thank you. So yeah, that's exactly it. So this webinar is part of it. We really want to educate people, answer as many questions as we can, and make sure we can grow this market as well as. And at Puro, our goal is obviously to match the best available science that we can, thanks to the research professors like Dr. Zhang, and hopefully certify more and more suppliers like we've seen today. So I'm just going to do the closing remarks now. I would like to thank everyone. Thank you for coming and joining this webinar. It will be available online as it is recorded. I would like to say a special thank you again to Keith Driver for helping me organize this. A special shout out also to our marketing team, especially Nicole Smith, with all the coordination for this webinar. And I encourage everyone to fill out the form. Give us feedback on how we could improve those sessions. It's a second session as a webinar for Puro that where we're showcasing really our suppliers. So we're really looking for feedback. What could we improve, etc. And if we haven't been able to answer any of your question in the Q&A, please send it to our contact@puro.earth email. We'll make sure to follow up with you and give you a definite concrete answer. We haven't been able to dive deeply in the methodology today. That was not the goal of this webinar. So I saw a couple of questions on it, but I'm happy to answer them after this webinar. So thank you, everyone. Thank you to all the panelists. I really appreciate your time and your help. And I wish everyone a great rest of your day.
Thank you, Timothy.
Thank you.
Thank
Bye.
you. Ciao.
Thank you.